And if you have any questions, if this is not working for you, put up a red sticky and I'll come and help you out. If you notice your neighbor putting up a red sticky and you know how to answer that question, feel free to do that. And if you don't have a pair of sticky notes, raise your hand.
I would like all of you to put your name on the list so we know how many people really came to this class. So please put your name and your Clemson username. If you're in RU program, please put your RU username as well. Thank you.
Yes? You just have a typo in let me know if that doesn't work. Okay, again, I need to see green stickies, so if you're successful, put them up. Your password will be the same for. Everything that we run on the software, you can actually just run on the Mac using except for the W. Except for the W. I think Close is installed.
It's just unzip data. Yeah.
It's not unzipping because there was a typo in the unzip command. It has to be unzip data hpc.zip. The swc minus doesn't need to do that. Sorry.
That one right there. Just drop the SWC dash.
You see the W get actually downloads. You see on the very top.
July 20th.
Okay, so mostly green stickies all around. Again, if you're seeing any red stickies next to you, please help them out. Let's get started with actually what this data is and what we're going to do with it. How many of you have ever used Unix commands before? Okay, that's a good bunch of you. So, all right. So here's what we need to do, right? And before I download this into the Palmetto, I'm just going to download it onto my local machine here and show you what the data actually looks like. Let's see if I can do that. Finder. There it is, okay. So once you unzip data hpc.zip, what it does is it creates this folder data hpc, within which there's actually a whole bunch of things. And the ones that the folder that we're really interested in today is is a folder that looks like this. It has a bunch of text files, and it also has this script called goostats. Here's what we want to do. I'll open this text file and show it to you. It looks something like this. And here's what it represents. Each of our text files are named NENE something. And the NENE stands for the researcher who made these text files, right? Her name's Nellie Nemo. And then she she went on an expedition to the North Pacific Gyre and collected a bunch of samples from some organisms. She ran each of those samples through something called an assay machine, and each of the samples produced an output that looks like this. There's basically two columns in this file. The first column corresponds to a protein ID, and so this is protein number 21, this is protein number 245, and the second column corresponds to the relative amount of that protein in that sample. Okay, and that's a mouthful, but be comforted in that this is all just a made-up example. So there's a bunch of text files. Each of them corresponds to one sample, and each sample has a bunch of proteins, each called 216, 270, 275, so on and so forth. And the second column is just the amount of protein in that sample. Does this make sense? Any questions about what our data actually means? All right. We have a script here called goostats that we can run on each of our text files to produce some sort of statistics from that file. And what we want to do is we want to run goostats on each one of our files. We can potentially have hundreds of these files corresponding to hundreds of samples. And so to run them on 100 samples, for example, using a graphical interface, we'd have to click and double click and hit enter maybe a few hundred times repetitively. And that's something we don't want to do. We want to automate that process. Right? Additionally, we want to do all kinds of neat things. For example, we want to look at a file and determine which protein is the least abundant and which protein is the most abundant. And we want to extract those results and put them in another file. And so on and so forth. We want to do all these cool things with our files, but we want to automate that process. Okay? And we want to use the Unix shell to do that. For example, if I gave you this file and I asked you to find the protein that was the least abundant, how many of you can do this? How many of you can do this using some programming language? How many of you can do this using the Unix shell? Alright, so that's not a whole bunch of you, which means that I guess we'll all learn something new today, which is always a good thing. All right. So going back to the Palmetto here, let's see if I still have this open. Okay. The first thing I do is I download the data, and let's see, Linux Workshop. HPC.zip. Whoops. Am I missing something? Let's see. There it is. Okay. And then unzip data HPC, zip, Okay, alright, so sorry about that. Just give me a second here, sorry about all of this. Okay. So I know I've downloaded data because I can type in the command data HPC, and it should tell me something.